Thanks, Kenneth. So, like Kenneth said, I'm going to tell you how we combined Nix and EasyBuild on our new clusters in Canada. So I have to go quickly through the first 20 or so slides to give you some background. So basically, the whole supercomputing environment in Canada is going through quite an upheaval, a big change, where there used to be some 20 odd clusters at most research universities to having just really 4 main compute clusters nationwide, which means that we're having a lot of reorganization, a lot of distributed teams at the moment. Many universities who don't have a cluster, a big compute cluster anymore, but still user support. So at the moment, we have 3 new systems online. One is Arbutus in University of Victoria, which is a cloud system. We have Cedar and Graham, which are since July last year, which are the big new compute clusters. Niagara is coming online a couple months as a large parallel system. And then Beluga is with the accent aigu because it's in French. It's in Quebec. It's basically going through an RFP right now, so it's not much I can tell about it, but it's going to be another system, probably quite a few GPUs. So the first of those is Cedar. It's a system at Simon Fraser University that's in Vancouver. And it has, as you can see, about 900 nodes, heterogeneous system. Most are Broadwell, and 146 of those have 4 GPUs each, so it has the largest amount of GPUs at the moment in ComputeCanada. And so combined with the GPUs is a peak theoretical speed of 3.6 petaflops. It's also going through an extension, which has another 2 petaflops, so we're going at 5.6. The other one that came online about the same time as Cedar is Graham at University of Waterloo. A little bit more nodes, but fewer GPUs, which means that the peak speed is a little bit lower than Cedar. But overall, Cedar and Graham are at the service. They're very similar systems. Niagara is different because it doesn't have TPUs. It's basically meant for large MPI jobs. So it has, or will have it under construction now. We'll have 1,500 nodes, each with 40 Skylake cores, and with an interconnect that's called Dragonfly, which is a bit of a innovation, because for these 1,500 nodes, there's no big core director InfiniBand switch. They use a Dragonfly topology, which means that all these edge switches are connected in a peculiar configuration, which means quite a big spaghetti of cables, as you can imagine. If you look at the slides, will be posted. There's some links in here. You can look if you want to know more about the details. So in terms of the software, when we designed this new system, we said instead of having a different software infrastructure for all these nodes, we want to have a similar user experience. So no matter whether a user logs into Graham or Cedar or in future Niagara, when they do module avail, module spider, things like that, they will see the same, they will have pretty much the same list of modules. Could be a few exceptions because licensed software, but overall, they should be able to port their jobs and say, okay, I can run this job on Cedar, I can run the same job on Graham, or vice versa. And so what we needed is a distribution mechanism. We could just copy all the stuff, but we chose to use CVMFS because it's a distributed file system that's been proved very useful in the past, mainly in higher energy physics. It comes from CERN. We also wanted consistency, so we wanted to have minimal influence on the OS. So the whole software stack should be able to run on multiple Linux distributions. Of course, if we do binary distribution, we restrict to x86. Some sites use power processors, but it's not really useful for general purpose in any case, because there are always people who want to run binaries, and sometimes they're just not available for these other processors. I see more use of power for specialized clusters, which do like one thing, like atomic weapon testing and things like that. So we use Nix to basically get OS independency for the most part, apart from the Linux kernel, of course, because it goes all the way down to glibc, as was said in the previous talk. We used EasyBuild to get automated installation, so instead of having handwritten build scripts that we used before and which get put away and then bit rot and things like that, we have a more consistent scheme of using EasyBuild to facilitate all the module installation. And easy to use, so we use LMOD with a hierarchical structure. Many of our LMOD ideas for the hierarchical structure are borrowed from Jülich. So it's thanks to Damien for inspiring our scheme. It's still quite different from Jülich, but the hierarchical structure looks a lot like it. So the design overview is that we have basically a layered approach, where at the bottom we have things that are not in the distributed system. This is the system administration domain. So it means the OS kernel, Linux kernel, any daemons that run on it, like we were mentioning dbus as an example, that's systemd, they're all daemons, we don't touch them. libcuda is another one, we need that for GPUs. Anything privileged, we don't mess with anything with, it's actually impossible to do chmod plus s on any binaries on CVMFS. So anything that needs privileges like sudo command, even SSH has a kind of key sign mechanism that uses elevated privileges. So SSH is in this layer as well. Some legally restricted software, for instance FASP, they don't allow us to distribute it in any form or shape, so we have to keep it local. There is a gray area of things that could be distributed or could be local. For instance, Slurm, the scheduler, it's local at the moment because it's basically managed by a separate team. The IB or InfiniPath client libraries like libib verbs and things like that, we build them using Nix and distribute them. It works. But it's something that could be done locally as well if you want to keep them in sync as part of like a big overhead distribution or things like that. Then we have the Nix layer. The Nix layer is its own little ecosystem. It's based on Nix package, much like previously explained, but we wrap that into a module by itself. So it's like our very much bottom module is called Nix package /16.09. I'll get to that in a moment. And we have that as a root, and by using EasyBuild naming conventions, one environment variable is ebroot Nix package. That just points to that Nix installation. On top of that, we have some EasyBuild generated modules around Nix profiles for things that we build using Nix, but we provide a module for. So it's like a static profile that you then point your environment variables to. And then on top of that, we have things that are built using EasyBuild, including multiple architectures, SSC3 for our oldest legacy clusters, and AVX2 is all the new clusters. In the future, we'll also need an AVX 512 branch. Sure. The mic is there.
Well, just on that previous slide, you put the compiler in the Nix side, like GCC in that? Is Nix provided? So just can you explain a little bit in that? Like, are you using the Nix wrapper?
We actually, I have a separate slide about the GCC situation, actually.
Okay.
Yeah.
I'm just very interested in the compiler part, because that's pretty
we don't wrap GCC. Nix has a GCC wrapper, but we decided not to use it because it gives us too many issues. We wrap LD. So one of the tools is CVMFS. It's a distributed file system. We use it to distribute things to other sites, and the advantages are that when we push it, it's there within a couple minutes, and that there are multiple cache layers. So if something fails, there's a different route for which the software can be obtained. So we have basically what they call a stratum 0, or we build it on the repository node and we publish on a stratum 0, like a central server for distribution, and then there's stratum 1s. We have 2 or there's probably 3 in the making stratum 1s in Canada. One is on the east side, one is on the west side. So if one fails, you can just get your stuff from the other stratum 1. And then on client nodes, which are all the worker nodes and login nodes, they can in turn also have like a squid node with a cache in between. So it's like a local cache. So this way we have redundancy and also performance, because once somebody needs something from CVMFS, it stays locally in the cache, and next time somebody wants it, it's fast. So to configure the client, we need what is called a public key, otherwise you can't access the files. It's not entirely open. Without the public key, you can't access the files. We have 3 main repositories. The first 2, soft and soft dev. Soft is the main repository, soft dev is just for testing, so we publish things just to make sure it works. Then you can mount it. That's fairly open. The restricted repository is not open. It's meant for commercial packages. It can only be mounted by people, by sites that have a very specific LDAP user scheme, and only if you have particular user IDs and group IDs, you can mount a repository, and then you can set group permissions and things like that and say, okay, this commercial is only available to this particular group and to nobody else. We have a lot of clients at the moment. We have a test clients. Here are 3 VMs for testing, and then cluster nodes within ComputeCanada. So Nix, for us, plays the role of an abstraction layer between the OS and the scientific software stack, which we do with EasyBuild. So we prevent, because we control the TLibC, we prevent a lot of issues with TLibC being too old. That's nowadays quite a common case, because you have these enterprise distributions and often packages are quite old. So a large part of EasyBuild, there's a lot of packages in EasyBuild that are very boring packages that are just things that are also installed via RPMs typically, but because CentOS 6 is very old RPMs, people want newer software, so you work around that by providing modules for AutoConf, CMake, what have you, which are not very interesting from a scientific point of view. So we basically provide all these things via Nix, and user main 16.09 profile is like a grab bag that has all these packages combined. Then we use EasyBuild and LMod, but I don't really have to explain these 2 tools to this audience, so it's a very short slide. So what we do, we have these recipes. Both Nix and EasyBuild have recipes. We know about EasyBuild recipes and Nix recipes. Saw an example in the previous talk. And then we decide where it goes. So typically, when something is performance critical, it depends on the MPI, it goes in EasyBuild. When something needs multiple versions, we put it in EasyBuild, sometimes Nix via EasyBuild, to have like multiple Nix profiles with different versions. And when it's something more boring, system-oriented, we put it in Nix. We install it. We have a special VM that's build node.ComputeCanada.ca where we compile stuff on. Then we test it on the build node. We can push it using an rsync to the development repository, test it on there, then push it to the production, and hopefully it will work straight away after all this testing. So this is what we do on the build node. We can install things using Nix and using EasyBuild. We can do that without sudo. This way things get installed in our home directory. That works both for Nix and for EasyBuild. Nix precisely as what's explained in the previous talk. EasyBuild by using your home folder /.local, and this works. And then often people play in their own home directory, just installing easyconfig in the home folder, and then when it works with your module in the home directory, we can use sudo -u EBUsers, have the EBUser special user to install things using EasyBuild globally on the build node. And then it needs to be pushed using a special rsync script. We start a transaction, needs to be locked using a special user. We start a transaction, we rsync it, and then we publish, or if we think, oh, oops, I made a mistake, I can abort the transaction and everything I've done from the start is cancelled. Now in terms of statistics, you can see that over the past year we've made a lot of progress in installing packages. We've now installed over 2,000 software modules, also Python wheels, including all different architectures. Here you see a big steep line. This means that we did a mass rebuild of things for SSE3. It still needs to be a bit more automated to automatically build things for different architectures, which is not quite there yet. But the main steady line is this blue line. This basically comes from tickets saying, I want software package X installed, please do it. So that's basically the blue line is human effort. We often need to modify the easyconfig a little bit, stock easyconfig, before we publish it, because the Nix environment sometimes need to make a few custom changes. In terms of the variety, a little bit of statistics of the category. The most common is bioinformatics, just because there are so many in bioinformatics packages, just that they have a huge variety of software. Next category is various tools. Doesn't mean that bioinformatics is the most used software within ComputeCanada, it's just because they have a larger variety of packages. In terms of installers, we have a large group of people who install our software. You see that Masao Fujinaka has been very productive. Unfortunately, he retires soon, so we'll sorely miss him. And then there's me, Maxime Bassonneau, and then a long tail of other people who are involved in installing software. Kenneth may recognize a few of these names because some of us have been contributing easy configs or easy blocks. We also have some commercial software using these restriction sums, some special cases like FASP that I mentioned before, because they don't want ComputeCanada to distribute it, so we say, okay, FASP is only provided by the individual clusters. It can be supported by ComputeCanada, but it's not provided by us. It's a very legal quagmire. And we have a module usage dashboard, a fancy web interface to track which modules are loaded. It's not entirely reliable because people load modules in the bash RC, but at least it gives us a way to see if modules are used at all. If we say we want to retire a module, say, okay, what's not in here? We can see that nobody uses it, and it may be safe to retire it, much like we discussed yesterday. Now, in terms of what we install via EasyBuild, we're not using the standard tool chains Intel 2017B and FOSS 2017B. We use some variations. We use the same components, but we just create our own tool chains. We have like a standard, most things we compile using Intel plus OpenMPI plus MKL. Sometimes with CUDA 8. That's like our default stack. Those modules are loaded by default. And we're moving slowly towards a new stack with updated components, TCC 6 and then Intel 2017.5. For some reason, Intel in their infinite wisdom, they had 2017 update 5, but the MKL was called 2017.4. I don't know why, but somebody thought it was probably a good idea. And we have other tool chains, so we have various combinations of these letter alphabet soup for combining TCC with MKL or without MKL, with OpenMPI, Intel MPI, PGI is there too. All these tool chains, we keep them hidden from users. Users only build a compiler, an MPI module, and a linear algebra module, but they don't see these modules unless they use EasyBuild themselves, which is also possible. For Python, we don't provide a lot of modules for the packages. We basically say to people, use virtualenv and pip, and to allow optimized packages, we provide a wheelhouse, so they download things from our wheelhouse instead of the worldwide internet or PyPy in general. Except for a few common cases like SciPy stack, really like people who just need Python and NumPy and SciPy and a few related packages, they can just use that module. MPI for Pi is a special case too because it needs a particular MPI version, so you cannot have a generic MPI for Pi. I mentioned it last year too, but we have MKL at the core level, which allows, unlike generally at EasyBuild, MKL sits at the top level. It depends on MPI and a compiler. We have it at the bottom level, which allows us to have tool chains that only have MKL and the compiler, but not MPI. And there's a lot of programs that do that. They need the linear algebra, but they don't need MPI. So we have a couple of packages like Julia, NemD using IB verbs, Octa, Root, Sweet Sparse. They don't use MPI, but they need linear algebra, so we don't link them to MPI. So those are generally at the compiler level. So if people load a different MPI version, they still see that in the module avail list. There is some work to be done here to push that properly upstream. There is some support for the IMKL toolchain in framework in EasyBuild, but the easy configs are still missing. It's long overdue to contribute that back. There's a configuration. We have a long list of settings. Just a few to point out is, well, one thing that's useful to us is the sub-tier user modules. So we allow users on the compute cluster to use EasyBuild themselves and compile software. We use that actually for Anaconda. So there's a miniconda easy config that we have, and we don't compile miniconda ourselves, but that allows them to compile, to install Anaconda or miniconda, and make sure it integrates properly with Nix, and it installs in the home directory via EasyBuild. And we have a long list of filter depths. Those are basically EasyBuild packages that we don't use EasyBuild for, but we use Nix instead. So they're all the boring things that I talked about before: Bison, Flexi, Make Curses, LibReadLine, etc. We do filter end parts of LD library path. We had a talk like that yesterday too. So because we use run path for everything. And we have this one Nix package module for the bottom layer. So we have to allow that, otherwise EB complains. It says this module is already loaded. I don't want this. So we have to disallow it explicitly. So now I have 5 minutes to go about a few challenges that we had. One is the non-standard prefix. So there's a lot of software out there that relies on stuff being installed in /user. It's not so bad with open source, because a lot of open source is already adapted to situations where things were not installed as /user. For instance, on Macs you have all these systems like Think and Homebrew and things like that, and they don't install things in /user either. So they've been already hammered by bug reports about that. So we're past that. It works pretty well, but sometimes we're bitten by the use of our modern style run path, which is used by Nix by default, instead of our path, which is stronger, but LD library path overrides the run path. And some people, some users set their LD library path, sometimes in old bash.rc files that they copy. Sometimes they are binary only software like ANSYS that basically sets it in the scripts that are included with the software. That messes things up. Yeah. So when you were
since you're recompiling this all anyway, did you consider using RPath instead of RunPath?
We considered it, yeah.
And why did you? What was? Like,
we didn't consider it until we found these issues. So now everything's already compiled. So now we'll have to recompile it.
In a future generation, you may decide.
We may use RPath because of all these issues. Yeah.
The big problem there is RPath is officially obsolete.
That's don't perpetuate that. That's garbage. It's never going to be obsolete. Like never in a million zillion years.
Yeah.
No. It's so obviously needed in this case and in other cases. It'll never be gone, and it's caused so much trouble them saying it's deprecated.
There are some complicated cases like bootstrapping GCC. In itself, it won't work in our setup because GCC compiles itself and then everything falls down without special patches. So then I say to users, your module -- force purge stores the whole module structure, and you can start with plain CentOS really. That's a nice thing about putting all the NICs setup in a module. We could even consider using Singularity because that basically can do an effective chroot from into /user. I haven't tried it. We have the NICs package model. This is an extract from it where we're setting a lot of environment variables to teach people software to look in our environment. One thing that I had to change a couple months ago is that I realized that I had to use C include path and C plus include path and not C path to point to the system include directories, because those two environment variables, they behave slightly differently from CPath. And that's something I didn't know before. I just figured it out. Hey, there's some things that don't work. Apparently, GCC considers header files that are in C include path slightly different from the ones that are in CPath. And there's some that are marked as system headers. And there's some things that it considers as errors when they're in a regular include directory, but when they're in system include directory, it is not seeing those as errors. So I had to really do C include path, and then some things just started working that didn't compile before. We had really weird errors, like compiling about _throw in header files. And what do we do about this? And how can this be buggy? How can catop.h be causing issues? And then with this little change, it worked. Sometimes we need to patch binaries. Maybe the commercial vendors don't like us doing that, but I think it's fair use. We have to use some very funny workarounds on ANSYS. We have a script, setrpath.sh, that basically can modify the run path inside script. It uses patch elf to patch all these binaries. And we also have to do some sed commands to basically, looks like line noise, but the idea is that it scans, in the post-install commands, it scans the whole ANSYS folder for scripts and finds any places where it tries to set environment variables to /user /something, and it replaces those. So these are some of the very hackish things that we had to do to run binaries from elsewhere. Then there's the issue with NICs store leaks. As was explained in the previous talk, NICs is held together by a whole bunch of symbolic links. Our NICs profiles in turn is a link to a generation, which in turn goes into the NICs store as a hash with a user environment. And then in the user environment, you have, for instance, ls command, and that links into the core utils directory. We try to avoid these leaking into the user environment because the users don't use NICs themselves typically. We can do that by basically using the profiles directory as a barrier that sits in between the store and what the users see. That usually works because we have a wrapper to LD, to the linker. But sometimes it leaks, so we had it with virtual env from Python. So we used to have a NICs wrapper around Python virtual env, but it caused the Python binary to be copied, and then the Python that people copied in a normal home directory depended on explicit NICs store paths, which could be garbage collected and didn't exist anymore, and then the Python from virtual env didn't work. So we basically worked around it by reinstalling Python using EasyBuild. Another problem is qmake is actually, I think, is a bug in NICs, because NICs has like 20 different derivations for Qt, and maybe we'll end up installing Qt using EasyBuild as well. Another challenge is Python. So we have a technique to bypass Python path by using a new environment variable called EB prefixes and a file named sitecustomize.py. Basically a little bit of Python code that scans that environment variable and then adds it to the environment. And this way we can avoid most use of the Python path, which sometimes messes up people's installation, particularly if they start playing with Anaconda or they have virtual env, and the Python path overrides the packages that they see in their virtual env. And the other advantage is with the EB Python prefixes, the version is added dynamically, so we can have one module for multiple Pythons. So we can have one module and say, okay, we also have Python support, and we have Python support for 2.7, 3.5, and 3.6 all in one module, instead of having 3 modules for 3 different Pythons. The other thing that's set up here is the wheelhouse. Yes?
How does that last part work?
Which last part?
Where you're sharing the same Python package installation with different Python versions. Because as soon as you use it with one particular version of Python, it compiles.
Yeah.
And those compilations are specific to the version.
Basically, the easyconfig puts the Python installations for multiple Pythons in multiple directories. One goes in Python 2.7, one goes Python 3.5, one goes in Python 3.6. Then it's dynamically, when you load the module, or when you run the program, it will see what Python module is loaded.
It will pick up the
And pick up, yeah.
So if you install a new Python, let's say 3.7,
Yeah, we'll have to reinstall the modules and add the new Python directory.
so it's kind of like an architecture.
Yeah, yeah, exactly. That's our other challenge, is multiple architecture. So we have actually a wrapper about the EB command that selects the architecture, AVX2, AVX, SSE3. One of the things about Damien is that how do we do an opt arch for GCC core? So we actually have it here, GCC core generic, and there was like this one-line change to set compiler family equals name in GCC core.py that made this work. But I'm not entirely convinced that this is not breaking things in other subtle ways. So, but it makes things work for us to get GCC core as an to get an opt-arch setting for GCC core. The other thing is that we let ICC iFort modules, or we call them Intel modules, dynamically extend the module path depending on the architecture, which is an RSNT arch environment variable. So anything under the compiler modules is compiled generically in the core level. And once you load a compiler module, you use a specific architecture. We have EasyBuild wrapping NICs, so this is basically what Robert's question. We install g4.6.cc here, for instance. This is like the NICs package without the NICs GCC wrapper. And that gets installed into custom profile, and then we install a module that wraps around that profile. NICs can also wrap EasyBuild. Robert played with that, but it's not being further developed. It's something that could be investigated at some point. He's shaking his head. Okay, but the one thing that was nice from your project that I could borrow some NICs expressions from that to wrap things like VSC base and things like that and install those via NICs. So all the steps that we take internally, how our build infrastructure is, if we want to go for a deep dive, we have a guide, very detailed. People read it first time and say, how much red tape is there involved? But the red tape helps to rebuild everything automatically. So it's a bit of a high barrier to get into, but it saves a lot of time in the future. So this is actually a public guide. You won't be able to do many of these things, but it gives you inspiration for what you want to do on your own side. So I went slightly over time, but thank you very much for your attention.
Any more questions for Bart? Yeah.
Well, it certainly does seem quite complex, to be honest. Apart from, maybe I've simply forgotten when we went through the challenges here, all the positives.
Yeah.
But apart from saying the system sort of level libraries as being part of Nix, what was other, if it wasn't for those libraries, would there be any compelling reason to involve Nix at all? Let's say those simply didn't exist.
Right. No, if Nix wouldn't exist, we would use something else that can install in a non-standard
prefix. But I
mean,
rather that's, I don't know, whatever is in GCC core.
Yeah.
Those system level libraries, if those were a non-problem somehow, apart from those, saving you from compiling those in EasyBuild and having additional EasyBuild modules.
Yeah. No, the thing is,
like ultimately, how do you feel about libc? Like, do you want to have the same libc everywhere, or do you want to?
Yeah.
And there's no way without runpath or rpath to ever allow you to have an alternate libc than your OS.
Yeah.
That's just there's no other way really to do it. And once you introduce that, even without Nix, like just introducing the idea of, well, I'm going to rpath or runpath in a libc, this is the mess. Like this just a natural consequence of that decision.
Yeah, we basically make the decision of make our environment as much independent as possible from the underlying Linux distribution. So we have everything that's user level, apart from things that needs privileges, are in our stack. So like I said, example is ls command, all these basic system level stuff is still provided by us as long as it doesn't need special privileges.
To get into that also complicates things, because now you don't have one OS to worry about with regards to security updates. You have two.
Yeah.
You have to do updates on your host OS. You have to do updates on the Nix level as well. You do everything in Nix. Yeah. No, but
I mean,
is that a concern? Like the glibc crap that's been going on?
Yeah, no, there are. We are immune to parts of those security concerns. I mean, nobody is able to get a local root exploit via our software stack. It's not because it's all user level. However, there's a chance of people leaking users to each other, users leaking users to each other. But there's nothing that runs as root.
You're also saying that if you're the software guy, not the system administrator, so it's not your problem that the system is.
No, but there is nothing that runs a system level. There is no.
There's root exploitations if the user is on the machine that they can exploit the old binary packages.
Yeah.
The OS.
Yes.
Root including kernel problems.
There have been issues in what was it? Bash? What's the Bash thing?
Well, anything that's
Heartbleed,
all sorts of things that are set UID.
Shell shock, yeah.
Yeah, no, but the thing is that anything we have in there, a user could put in their home directory. We use no special privilege to do that. So a person, any user on the supercomputer can install a glibc from 10 years ago that's full of security holes and use it, and nobody will know.
He's talking about the ones that are like the set UID binaries that are on the OS. And
yes.
The things that those things are dependent on that are OS dependencies.
Yes, and they are all their own little world.
So you're basically saying that, of course, you have to worry about security updates in the host OS.
Yes.
But on a Nix level, it's not really an issue because it's just like a normal user would do.
Yeah, it's just like a normal user is do. That doesn't mean we're completely immune, because if users run web servers and they are leaky, but it's conceptually the same as a user compiling their own software, putting in the home directory and running their web server that way.
You can't control anyway.
We cannot control that, but the difference here is that the user is responsible for their own damage. In this case, we are responsible. So it's more of a, it's a different perspective. But in terms of technical issues, like a local root exploit, no, that can't happen because we specifically exclude the ZUID stuff.
Yeah, but I guess they can get access to your, or become the software user, and then if they want to measure all the software installation that you have done with that user, I guess possible.
No, they would have to hack into the build node to get that.
Everything else is redone.
everything else read-only. So whole CVMFS stack is read-only.
All right.
Like the individual clients, the compute nodes, etc., they mount CVMFS, but it's all read-only. Okay. So when like Nix in the previous talk, as is in Grenoble, if you want that setup, you need a separate Nix installation. So actually on Graham, the local people have set up a separate Nix installation where people can install things via Nix themselves. That doesn't work here because it's a read-only repository. The whole Nix store, it's immutable. Yeah.
All right, thank you, Bart.
You're welcome.
You'll be around until tomorrow at the end, right?
Yeah.
Excellent. So next up is Louis, who came here by invitation to talk about Docker. So to continue the container wars in HPC,